All right, looks like it's time to get started. Thank you everybody for showing up for the session. I wanted to talk a bit today about static analysis, and in particular some important breakthroughs and state-of-the-art technologies that currently exist with static analysis for Java. But before I get going, let me do a brief introduction to myself. So first off, my name is David Lindsay. The conference talk was originally listed to be presented by a good friend of mine and coworker, James Croall. He was not able to make it, but I am here in this place. So let me tell you a little bit about my background. I studied mathematics at the University of Utah, got my master's degree from there. I moved into software space as a software engineer right out of college. I quickly realized that I had a knack for not necessarily writing code, but for breaking code. And I realized, doing security testing actually was kind of a good fit for me. And so I started focusing on breaking applications by working as a pen tester and doing code reviews and working really closely with developers, but kind of from the breaking point of view. But so I did that for many years as a consultant. And then about a year and a half ago, I started working at Coverity. Coverity is a tool company. We have a static analysis engine that's state-of-the-art that focuses on C, C++, and Java. So that's kind of who I am and where I've come from. And so going through the talk, I'll be talking a little bit about just things purely from a static analysis point of view, but kind of with a slant with security as well. So kind of just in terms of my presentation today, I'll go into a little bit more detail about my company, but real brief. I don't want to waste a lot of your time with that. Talk a bit about what exactly is static analysis. Talk a bit about what you can actually do on Java code from a static analysis point of view. Why does it produce good results to begin with? And then we'll look at some actual real-world defects that a static analysis tool can find. So Coverity has been a pioneer in the static analysis space. We began as a company, as a result of research done in Stanford University back in around 2003, 2004, and the company has been always been very academic focused, which was one of the reasons why I really like the company. And that kind of lasts even to this day in how the company operates. We do comprehensive testing for different types of applications. I mentioned C, C++, and Java. We also do C# and are looking to expand into other languages as well. One of the things we're known for, though, is rather than focusing on a breadth of expanding rapidly and cover as many languages as possible, like some other tools have done, we really focus on in doing the languages that we do support, doing them really well and going really deep in those languages. And part of our focus at Coverity has always been on the developer, and this is especially true in the security space, where a lot of other tools focus on having kind of a tool that a security auditor could use or security specialist, but not necessarily something that works for a developer. And it's really, a different kind of audience, a security person versus a developer person. And that's really always been, we've always wanted to be the tool that developers can run on their desktop to find both, quality issues, security issues, and so forth. And there's really a lot of advantages to doing development testing, and being a tool that integrates well with in the software development lifecycle. And that's because you can actually do testing much sooner. This is one of the mantras of agile testing, for example, is that having short feedback loops is good. And if you only do security testing or any type of testing at the very end, then you actually you have it could be months between when a piece of code is written and when the testing occurs. And if you can shorten that down to days or even hours or minutes, that provides a huge advantage in terms of being able to quickly spot things and get them fixed much sooner. And the cost to do so is actually much cheaper as well. So I've talked about static analysis a couple of times. I want to make sure it's clear, what exactly is static analysis? Well, there's, lots of different ways you can test your code. Static analysis is one, and that's a way where you actually look at the source code. It's looking at the application in a non-running state. And that's in comparison to dynamic testing, which is looking at a running application. Both of these are very valid, important testing techniques and are very complementary. Both can find a wide range of defects, and they both excel at finding different types of defects. So, for example, some type of defects like, finding sensitive data or like a hard-coded password in your source code, that's generally not a good practice. And that's really easy to spot statically, but dynamically, that's very hard to do. If you flip it around, some things are very easy to spot dynamically that are really hard to do statically. So both are really valid, strategies. So within static analysis, there's also, different ways you can do it. You can look at just binary code, you can look at source code. And we actually, as a company, we originally started focusing on, doing bytecode analysis. But we realized that if we switched over and focused on the source code, we could actually be a more useful tool because we could provide more actionable remediation advice. We could, exactly tell the developer what in their code they needed to do to fix a defect, for example. And so we switched over, and our analysis now is much deeper because of the fact that we do analyze the actual source code. So can I get a raise of hands? I'm just curious how many people actually have used some sort of static analysis tool. Find bugs, for example, would be a good one. SonarQube has a very commonly used tool as well. So I see the majority of the hands go up. That's good to hear. So there's obviously a lot of open source tools in this space as well. And in a minute, I'll talk a little bit about how we differ from them. But it's very heartening to see that so many people are using some sort of static analysis testing tool. For those of you that are maybe new to static analysis, I just wanted to kind of give a plug for maybe why you should consider using it to begin with. And the best way I can do this, I think, is kind of using an example. So my wife, she is a writer. She's written poems and short stories and working on, longer full-length books. And she oftentimes will, come up with a story and want me to review it and just kind of check it over and find, and sometimes she's looking for very low-level, details like, is the grammar correct? Did she, is there double words? And that level of, polish, to polish off her writing piece. But sometimes she just wants much higher level feedback, like, does this flow well? Does this, does the plot make sense? Did I introduce this character too early? Those types of things. So there's all sorts of different types of feedback and criticism I can give her. And I am a horrible writer. I do not write. But, just the fact that I'm an independent third party for her, means that I can still provide valuable feedback. It's very common, for example, some, paragraph that she's written, she's read it over and over hundreds of times. And there'll still be like a very obvious mistake in it, like a word repeated twice or something like that. And for me, the first time I read it, it jumps out to me immediately. But the fact that she's so familiar with this writing, she doesn't even, notice it. And I think that's really, the same kind of review and third-party viewpoint is really helpful from a code writing point of view as well. If you get so into writing your code and I'm sure everybody in this room is a much better coder than I am, but having a third party, somebody that can look at your code and be like, oh, you know what, there's something really obvious here you missed. That's really valuable feedback. And to really make that scale, that kind of third party feedback, having an automated tool that do that can really be valuable. And like I said earlier, it's not going to find everything, but it will find a lot. A good tool can find a lot of very important defects still. So how exactly does a static analysis tool find defects? So there's no one way. There's actually lots of different techniques, and I'll mention just at a high level a few of them, and we can discuss some of the details afterwards if needed. But one of the core things we do is look within a particular segment of code, what we call inter-procedural analysis, and look at different code paths on how like from where an object is created to where it's used, and look at the different branches of the code to see if certain conditions can be met or not met, and we can identify defects that way. We can also create kind of a summary of a method itself and then look at how different methods interact with each other. And that's what we call inter-procedure analysis. So this is kind of looking at kind of a higher level view of the source code and seeing if there are certain patterns that match that can indicate that there is a defect. So this is getting more on the security side of things, but data flow analysis actually is actually a very useful technique. And this is where you look at data coming into your application. In particular, you're looking for untrusted data. So data that a potential attacker or a malicious user might have control over. And then you look and see where that data enters the application, and it's going to get passed around the code, and then at some point it's going to end up someplace, say being written to the database or written back out to the user in a web application as part of the HTML. And so we call these the sources and the sinks. Where the data comes in, that's the source for the tainted data, and where it reaches the sink is where it's going out somewhere. And by looking through those paths in the code, we can identify places where perhaps untrusted data is getting written to the database in an insecure way, and that could allow a vulnerability such as SQL injection to happen. So data flow is a very powerful technique, especially on the security side. Another checker that we have that's a little bit more new, but actually really useful in a lot of cases, and that's just kind of doing a statistical analysis on certain patterns in the code. So for example, if you call a certain method in a certain way, or you override a method in a certain way 19 times, but on the 20th time we see it, you don't override it in the same way, we can at least flag that and say, hey, this looks suspicious to us. You did it this other way so many times, maybe you meant to do it this way as well. I'll show an example of this in just a minute too, and how that kind of a statistical analysis can work in the real world. So we talked a bit about the types of analysis. So the next question is, well, what types of defects can actually be found this way? I'm glad the screen here is so big because I used kind of a small font here, but there's actually a lot of different types of defects, and so I'm not going to go through them all, but you can kind of see for yourself. So a lot of the web application issues that are listed here fall into that data flow category, where you have untrusted data you could come into the application, and if it's not properly sanitized at some point, then you quite often find yourself with one of these types of issues like cross-site scripting or path traversal. There's things like resource leaks where connections aren't properly closed. There's concurrency issues and race types of issues, race conditions that are very common. Well, maybe not that common, but certainly I should say they're very severe when they are present, or it can potentially be very severe. There's just instances where the programs crash, things like infinite recursion or infinite loops. From a security point of view, we often call these denial of service types of situations, but from a quality point of view, it's just the program hangs, or so what else? So there's different things we can flag just in the API. There's just basic logic types of errors. And the list goes on. So there's database operation type of errors, error handling, unchecked return values, control flow issues. So all of these are defects that happen in the real world, and that can be detected statically. And when you actually get down to it, there's the breadth of issues that can be detected statically is actually quite broad. There's always going to be some things that just can't be done this way, but when it gets down to it, you actually can do a lot just from a purely static point of view if you do it the right way. So just to give one example, so one of the checkers that we have is called Null Dereference, and we look for instances where you check for a null value before you use a value, but then in another instance you don't. So that could the check for the null value could happen earlier on in the code, and then the use without the check could happen later, or it could be in the reverse order where the use without the null pointer or without the null check happens first, and then the actual check comes later. And so this is something where we can spot in your code if you're in some cases you are checking for null, but other cases you aren't. Either the null check is unnecessary, or maybe you forgot to check for null in a certain case and you want to fix that. So this is one good example about how we can do both inter or intra-procedural analysis to find a defect. So resource leaks are another common issue. Now, even with a language like Java, where a lot of resource management is handled automatically, there's still some situations where you either want to manually do it, or it's needed that you manually do it. So things like database rights or database statement objects, file handles. These are all things that can be handled manually and can lead to also denial of service type of errors if not handled properly. So threading is another issue where if you look at field access within locks, there's certain certain situations where this can obviously cause problems, deadlocks, or I forget the word off the top of my head, but so in this case, we'll look for a pass where it's possible to take the, where it's possible to take the same two lock objects, but in different orders. And in this case, it's a prime example for where a deadlock can happen. So I mentioned earlier this copy-paste type errors, and one good example of that, is here. So just take a look at the code, and this is an example where the top part has, the bottom part is a copy of the top part for the most part, but they, the developer, for example, wanted to change a particular variable all throughout the lower method or the lower code segment here. So do you spot right away where the issue is? I mean, you can see that, that in the first line, the returns value is changed to locals and that it's changed in a lot of other places as well. But it can be really easy to, miss one case where, you don't do it right. And so like in the second case, on the last line here, they probably meant to put locals there on the last line rather than returns. So this is a good example of how if we do some sort of statistical analysis, we can find instances where this kind of pattern happens. And talking with customers of ours and looking at actual real world situations, this is has a lot of surprise value for people who are like, wow, that's really cool that you can even detect it statically, and because it's not a priori it's obvious that these types of things can even be found. But customers are usually surprised and it's like, yeah, that's an obvious bug right there. And so it's always nice to see that happen. So, when I asked, raise of hands, about who's using static analysis, I bet you the majority of people here are using, find bugs or SonarQube or other types of open source tools like that. Just out of curiosity, by a raise of hand, anybody using a proprietary tool or a paid tool like Coverity? So I do see, it's hard to see with the lights here, but maybe a couple hands, that's it. So that's fair, it's, there's a lot of, good tools out there that are open source that can find things. The example I like to, use in this case is that, a tool like FindBugs is a really good, stepping stone for doing a deep analysis. It's, compared with not doing any static analysis at all, it's great, it's, you'll find lots of important defects using FindBugs. But on the other hand, it also is a tool that focuses on, it's a tool that focuses on more like coding style types of issues and best practice violations, those types of things. And there's a few higher severity types of issues as well. But to compare it with Coverity, that's really what our strength is. So the example I like to give for this is, my daughter, she's 8 years old and she's been taking swimming lessons for the last, year and a half. And, it was, at the beginning, she didn't know how to swim. She'd be afraid to even put her face in the water. But, over the last, 18 months of swimming lessons, she's really progressed, well, significantly where she can now swim. She can do a front float, she can do a front crawl swim. She can do a back swim. She's learning how to do the breaststroke and the butterfly stroke. She's really getting proficient at all these different types of swimming techniques. But to really get to the next level, she's getting close to the end of the rope in terms of what she can do, just from a lessons point of view. And to go to the next level, she'd need to start competing, actually. And they have kind of, for kids at her age, they have kind of, a competitive league where she can go and try out. And so really, for her to step up her swimming game, if she chooses to, she'll really need to kind of, step out of the private lessons and actually go into, join one of these competitive leagues. And so I think it's kind of the same with like FindBugs versus a tool like Coverity. It's a really great starting point to use a tool like FindBugs and get you the habit of, regularly, looking for these types of defects and even getting to the point where you're not making the defects to begin with. But then when you're ready to take it to the next level and use a more serious tool that goes a lot deeper, that's where Coverity can really step in and help out. So I wanted to kind of drill into some of the details in terms of what's actually different with Coverity. And I've talked about how we focus on, specific types of, higher severity defects. So this is an example. The previous slide and this one kind of, breaks down for application that we tested, just the types of issues that we find versus find bugs. And, in this case, resource leaks, we found 108 issues, find bugs found 34. So, again, we're finding similar types of issues. They're both resource leaks, but there's only 8% overlap between the two. And it's kind of the same for a lot of these other categories as well, concurrency problems, unhandled exceptions, and so forth. And as you can see, kind of all together, Coverity focuses on some of these more severe types of issues, whereas, find bugs, for the most part, falls into this low impact category, at least as far as we're concerned. So I don't want anybody to feel bad for using find bugs. It's a great tool, but like I said, it's usually a good stepping stone to move on to a more, deeper tool. Oh, and the other thing I like to mention here is that this analysis we did was all without our security checkers enabled. So if you include our security checkers as well, then you'd have even more of those like high severity types of issues as well. So I wanted to show, some of the types of defects that we find. And the way our analysis works is that we kind of wrap your whatever build tool you're using. Our tool is out of the box, kind of a command line driven tool. But we integrate into a lot of build systems and IDE type tools. But underneath it all, we're just a command line tool. And so if you're using, for example, Maven to build your code, you can easily wrap that Maven command with our cove build command, and then we will just monitor the entire build process as it naturally occurs, and pull out the bits of information like as the abstract syntax tree is built, we'll pull out that information because we'll need that later on when we do our analysis. So the first step is just to monitor the build and pull out the information we need. The second step then is the actual analysis, where we'll go really deep in identifying issues in the code itself, and then the third part is where you actually want to see the defects that have been found. And so once we have the defects identified, we store all that information in a database, and then you can log into our web GUI type of interface, very similar to Code Sonar, for example, and then you can actually view the defects and get statistics about everything. And the tool that we have to do this is we call it code. It's a very developer-oriented tool. So we want to, the fact that we are operating on your source code means that we can actually take you back to the source code where we found the defect and show you exactly what went wrong, and even step you through the code. Since a lot of the issues, it's not just a single line of code. It's oftentimes, a pattern, a trace through the code, whether it's, within one file or multiple files. So I will show you the actual web interface in just a second, but one of these issues I couldn't show, so I just have a slide here to demonstrate it. So this was the Apple goto file, which raise your hand if you've heard this. It's nice to get audience feedback here. So at least a few people have heard. So this was actually a really big security issue. And so I'm hoping that lots of people were made aware of it. So the code itself actually is really kind of just a really simple, obvious mistake. But this was a piece of code in the library that Apple was using to check certificates. And you can see here, that our tool is highlighting that there was a second, a goto fail line here. And the fact that there's two of them meant that the second one, was part of the first one is part of the if statement, so the second one is not, and so it's always going to get executed. And so regardless of whatever code path you're following, once you hit that second goto fail there on line, what is that, 92? So once you hit the second goto fail, everything after that will get skipped until the fail itself. And so that actually meant that in certain situations, important parts of the certificate checking process would be skipped over. And so although this was not necessarily one of our security checkers that detected this, because it was happening in very security critical code, it still was a very important defect. And so and the fact that this is such an obvious thing, like it's anybody who's doing a code review on this should easily be able to pick this out. But the fact is this was present in the code for years before anybody detected it, and that's because it's really hard to look at large code bases manually. This is kind of a good example of why automated tools can really help out. So. Oh, there we go, the highlight. So I want to switch over here real quick to my browser window so that you can see a couple others. So let's hope this works here. Okay. Oh, got to go back. There we go. Okay. So So this is the dashboard that we have for viewing defects that we have found. And like I said, we try to be very developer oriented. And so we have the source code here that you can use to step through your application. I'm not going to do a lot of stepping right now since I'm not trusting the Wi-Fi here entirely, but I should be able to show you at least, what's going on here. So this first issue that I have highlighted is a SQL injection type of issue. So I talked about this a little bit earlier where we have a data flow analysis. And in this case, you're looking for untrusted data that somehow enters the application and ends up being used in an insecure manner. So in this case, at the beginning here, this is where the untrusted data is coming into the application. And in this case, it's being stored as the variable hint. So right here is where the data is coming in. And then there's a few steps through the code, but if I jump to the end where the code is being, in this case, is being the potentially malicious data or tainted data is being written to the database, you can see that right here. So it's the same variable hint in a couple files later, but it's being directly concatenated into this select statement, and this is a prime scenario for having SQL injection. So I skipped some of the middle steps, but there's no sanitization that happens between the source and the sink, and so this would be a real world a real type of SQL injection scenario. So kind of similar to that in terms of talking about data flow is Crosssite scripting. Is this, just out of a quick raise of hands, are people familiar with Crosssite scripting? Oh, good. So I say that because I've spoken at several security conferences in the past, but very few developer conferences. And so I'm really excited to see that developers actually know about these types of security issues. So in this case, SQL injection, is a case where untrusted data is entering the application and then getting written back out to the screen, either on the same page load, or maybe it's getting stored temporarily and then being written back out later. So in this case, we have, request.get parameter is reading in the, get parameter answer. And then just a few lines later, we can see that some HTML is being constructed here. And as part of that HTML that's being constructed, the variable is being written to the response. And between those, 5 or 10 lines of code there is no sanitization that happens on this variable. And so it's a very direct, classic example of a reflected cross-site scripting issue. I only have a couple minutes left, so let's see. I'm going to show one more issue here. So in this case, we have OGNL injection. So this is, a kind of a dynamic language that is part of struts that allows you to, execute code using OGNL. And so, in a normal, code injection scenario, it would be a case where Java code is being executed, or where, say, like the bash security issue that came out about a month ago, where untrusted data could be written to an environment variable that later on got executed by the bash command prompt. Well, in this case, the same thing can happen, but with OGNL. And so you have untrusted data getting into the application and then being used in a situation where that OGNL will be dynamically executed. And this can allow the same types of things as more traditional types of command injection to occur. And so we've actually worked closely with some of the struts developers to identify some of these fundamental issues in the struts framework itself, and have got those fixed. So the last thing I'd like to mention here real quick. So I wanted to talk about how you could use some of the steeper static analysis technology yourself. And we have two options that are both free to use. So the first is what we call Code Spotter. This is kind of a new product that we've released where we do our same core analysis, but we do it in the cloud. And that way, it makes it much easier for developers and enterprises to get their hands on and actually doing an analysis. And so right now, we're in a kind of a quickly advance here. So right now we're kind of in a beta testing phase, and so for now you can do the analysis in our public beta completely for free. So it's actually a really, really good option for people who are willing to upload their code to the cloud. I understand that's not everybody, but for those that can, it's a really good choice. And then one other option here, I think I got to go back a couple slides. So the other option that we have is what we call Coverity Scan, and this is our free are offering to open source projects actually. And so any open source project can make use of our analysis by using the same process I talked about, where they first run the build step, where we wrap the build process and compile some information that we need. Then you upload all that to one of our servers, and we'll do our analysis in the cloud and present back the results. In this case, for open source projects, having the code being shared like that isn't as much of an issue, since the code's already public. And we've actually we've gained a lot of traction with this over the past few years, especially with some really hardened security folks. Like I like to point out the Linux kernel project, for example, is one of our main users in Coverity Scan, and they have analysis that runs every week and have fixed a lot of defects as a result of this program. So if you're using if you're an open source developer, this can also be a good way where you can use our see how Coverity works. So with that, it looks like I'm out of time, but I'll stay up here if anybody has questions. So thank you, everyone.